everyone, welcome back to my channel EduVibe. Today we will start with another topic of matter and chemical bonding, which is the VSEPR theory. So the VSEPR theory is a very important topic. We will know that what is VSEPR theory. VSEPR theory basically is the 3D structural formula for any molecular problem. So let's deal with what is like VSEPR theory. So the stereochemistry is the study of the 3D configuration of molecules. When we're talking about the 3D configuration of molecules, so then we're talking about the VSEPR theory. So the VSEPR, the full form is the valence shell electron pair repulsion, where the valence shell electron then they pair and then they do the repulsion. This states that the pairs of the electrons in the valence shell of an atom stays as far as possible because of the repulsion of their negative charges. Valence shell of electron kept so far as that the repulsion of the negative charges do not do that because of the very repulsion of the negative charges. The molecular shape is determined by the position of the electron pairs, where they are maximum distance apart and whether they are bond pairs or the lone pairs. So molecular shape depend on that they have the bond pairs, but they would have their lone pairs, and the position can be uh, occurred by the maximum distance they are apart from the lone pair or the bond electrons. So the order of repulsion is that lone pair and the lone pair is greater than the lone pair or bonding pair, greater than the bonding pair and the bonding pair. So this is the way like not like you have to know that, but you just know that the molecular shape is determined by their bond pairs and the lone pairs. So we will learn that how the bond pairs and lone pairs can change the 3D structure when we do. So there are four, five, six. So there's 7 types of we have to stereochemical formula for the VSEPR theory we have to know. So there are some VSEPR class, like we have some VSEPR class, and they have a things over there that these are the formulas for the we have to know that these formulas we have to know, not the other than this. Then we have a geometry, when what type of shape they have. They have linear, triangular, pyramidal, tetrahedral band, or like things. Yeah, the stereochemical formula, the main formula, which the VSEPR theory knows that, and the which VSEPR theory is denotes by these types of things. So these are the stereochemical formulas for this, and we have their bonded regions. Bonded region, like the things which are bond, is denoted by X. This is the X, and the central part is always the A. The denoted by this A, and the lone pair, if the any atom has, so it denotes by the E. So what is lone pair? So I will tell you that how the lone pair can look like in anything, and we will do some code examples too. So there are some of them, like if we discuss, like we have some. Firstly, we have this type of Lewis structure, and this type of Lewis structure will the linear one. So this will call the linear structure, and the stereochemical form like this. This type of structure we have that AS3, and this is AS2. So AS3, and this type of thing they have. So these type of thing that we have called the triangular pattern. Then if we have this type of thing, so it's a tetrahedral, and this is AS4. This type of thing we have to make AS4. And what are those? We have to I tell you that this is how. So next we have this one, and this is AS3E. So now the E is there. So E is the lone pair, as I told you. This is the lone pair, and this has a one lone pair. All has 0 1, but this has one lone pair, and the lone pair is that one. This was the lone pair. The end, which is that two bonds with that pair, that one pair of electrons which do not connect with any of the element, is called the lone pair. You can see that there are all the things are connected to each other, but in this, these are not the like connected to each other, not like bond with each other. So this has the one lone pair. So as we write over there, E, and this is a triangle pyramidal, and this type of thing we have to make in this. Next we have this type of structure. This structure also have the lone pair. One lone pair is have, so it's AS2E. This is the band, and band can be made like this. Then we have this. This have also two lone pairs now, so E2 we have to write, and this is band, and this type of thing we have to make like this. This one, this are 3 and 1 X, so ASE3 linear, and this one. like very confusing part, and this is not like you have to memorize this very immediately when you do this. Like these things you have to know. So this all the geometric and the geometrical formula you have to know. You have to memorize this, because when we get the questions, we get questions like in Lewis structure, like we have question in the empirical form, like this one. So we have to mainline geometrical formula like these ones, not with A or S, with like actual CH4 we have like with elements. So for this, you have to know the seven of them. So you get either all the seven of them. If you know that, you can easily make the things. And as I told you that the A should be the central atom, S is the satellite atom which like goes over there, and then E is the lone pair. If they have lone pairs, we have to know that. So when we get the question, we have to make that Lewis structure first, then the VSEPR class, this with this VSEPR class. We have to know the geometry of this, what type of shape of this is, and the stoichiometrical calculus formula we have to make. This is important. And if you take it which the lines that you know, this line, that dotted line, and that triangle colored line. So if we have that single line, this single line means that plane of page, like the plane, and the plane you have that page. Now I have that line or the plane of the page. If you have like dotted line, so it is into the page. So when it goes into the page, so it goes like this. And if you have like this type of thing, a colored part of thing, which is like in tetrahedral or the triangular pyramidal, so this line is called the out of the page. So these three things and these three things, like just to have to know to make the stereotypical formula. But this is easy. If you made the geometric class, if you made the VSEPR class, so you can tell that this is what is geometry and how that we made that geometrical formula. So to make this, so we have the first one, so we have to make a stereochemical formula for CH4. How can we make this? So firstly, we have to make the Lewis structure for this. So Lewis structure is very easy, as I tell you how to we made this. As I told you that in the previous lesson, that the Lewis structure is like the dot structure. So Lewis structure, so C, so 1, 2, 3, and 4, they have the letters of 4, and we have 4 hydrogen. If you want, so you can make the structural formula too. Structural formula is also look like this. So this is your structural one. But basically you have to make the stereochemical formula. So that C is in the center. So center is denoted by A. That H is goes like these. And you can see that not any of the like one pair, all the pairs are connected with one of the element. So there are no lone pairs in this. So we have 1, 2, 3, 4, 4 of the satellite atoms, which is H4. So you can make AH4, which is if you are not you're not learned this by now. So if you have to learn this, but if you not, so I will tell you that AS4 is a tetrahedral diagram is like this. So the shape we have to know that this is the tetrahedral, and how can we make the that for those C is at center, we have that into the page, so it's H. We have one plane of the page, two of plane of the page we have, and one we have that out of the page. So this is colored one, and you have to make that H. So you can make like this type of structure with CH4. So this is called the stereochemical formula. How you can make that anything. So let's do one more, and we have to make now stereochemical formula for CS3COOH. So this type of question like something confuse you. So this type of question like some of the tricky part goes on. So how can we do this? I'll tell you. So firstly, make the Lewis structure for this. So Lewis structure. So we have two C's in this. So one C with the 3 of the hydrogen. So we made 3 hydrogens like this, and we have one over there, and we have one connecting to one other C. So that C is connected to two O's. So one O like this we made. So this O like look like this, and the other one we made like this, and this O goes over there, and this is like one O goes with this and one O goes with H, and the other two pairs of letters we made like this. So you can see over there like we have the bit structure, and that type of structure is not over there. You can see that no any type of this structure we have over there, like so bits one. But if we put the parts of this, if we do the parts of this whole, so we can actually make some two to three parts of this. So how can we make this? So firstly you can see like this one, only this one. So this one, that C is like, if we notice C as a central one, so we have 1, 2, 3, and 4 of this. So if we talk about these two, so we have one central one which is denoted by A, and we have only one, and X we have 4 of them. So made the X 4. As we made in previous question, is a tetrahedral. Now if we look into this one, if we made this as the center, this C as the center, so we made actually 1, 2, 3 of them. So now we have 3 of them. So now this 1, 2, and 3 of them we have. So this means we have A as 3 for this. So as 3 is our triangular panel, this one. So this one is our triangular panel, which is ASE3. So for the last one, if we made this as the center, so this as the center, so we have 1 and 2. So we have 2 of this. But you can see that over there we have 2 pair of electrons which is denoted as a lone pair, which are not connected with any of the element. So this means we have 1A, we have 2H, and we have 2E's. So you have AS2E2, which is, so from here if we see from the table, so this is the bent type of thing. So this is bent. So now we have to make that structure with that 3 of the things, and we have to make the stereochemical one. So to make this, firstly we have to make the AS4, which is for this. So this has to be made by C is the center. So this is 1H, this is 1H, this is 1C we have, and this goes out of the page. Triangle we have H. Now this C is the triangle panel. So this goes with like one of the O and one of a line, and this is the O we have. So we can make triangle panel like this one. So all are the into the page, the plane of the page. So at last we have the O that has the 2 lone pair, which is E2, and we have 2S, one is C and one is H. So like this you can make the stereochemical formula. So that's how, if we have like so big type of Lewis structure we made with our formula, this is nitric acid. So you can make like this. So you can divide this by 3 to 4 parts, and you can make maximum 3 you get. So this is a big question if you get 4. So that's how the VSEPR theory works. You have to memorize this whole table. I have a trick for this to learn this. So in the separate video we will learn this about it, how can we make that VSEPR diagram so easily we can make that table. So we will discuss this by upcoming videos, and by the end of this video we will discuss that how can we make this. So that's all for this lesson. So we learned that how can we make the VSEPR theory actual. VSEPR theory is what is, and we have to make stereochemical formulas how can we make. So that's all for this lesson. In next lessons we will discuss the more theory part, and we can go into the end of this unit, and we are at that unit. So let me say, we EduVibe learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.